Hi guys, today we're going to look at page 19 of the Unit 2 Classwork packet. Our topic for today is sequences of transformations. Now think first about what a sequence is, right? Sequence, or a sequence, is really like something happens and then something else, okay? So a sequence of transformations is like saying I'm going to take a figure, I'm going to do something to it, and then I'm going to do something to the new figure, right? So it's essentially just a couple of transformations that are performed one after the other, and in some cases then after the other, okay? The important thing here, the first time around, I use the original coordinates, but then each time I do another transformation, instead of going back to the original, I'm going to perform the transformation on the new coordinates. Let's see what exactly I mean by this, okay? Now we're going to show this one of two ways. You can approach these kind of problems graphically, but my personal preference is to actually approach them algebraically, which means using coordinate rules. So with no further ado, let's start off by taking a look at example number 1. Okay, so example number 1 gives me the following coordinates, x, y, and z, right? So I start off with -3, 7, -2, 1, and -5, 2. Okay. So I'm going to start off by showing this algebraically, just so you can see how easy it is, and then we'll show it graphically, just in case you're kind of like a visual learner and you prefer that particular method. Okay, the first transformation they're asking us to do is a reflection in the x-axis. Okay, do I know a coordinate rule for that? Yes, I do. The coordinate rule for that is x, -y, where all I do is I switch the signs of the y's. So what I'm going to do is I am going to simply write the new coordinates after that transformation. So I'm going to keep all the x values the same, right? And then I'm going to take all the y values and change their sign. So far, this is not anything different, right? This is exactly what we've done before. Now, they want us to do a translation. Let's see what the translation is that they're asking us to do, okay? I'm going to do this one in orange. They say they want us to do x plus 9, y minus 7. Oh gosh, not y minus 7, I can't read. Y plus 2. Oh my lord. Anyway, so in other words, they're asking us to do a translation 9 units to the right and 2 units up, right? So that means what I'm going to do is for each of the x values, I'm just going to add 9. Again, what am I adding? I'm simply adding 9. That's how I'm getting these numbers here. And then to each of the y values, what am I going to add? I'm going to add 2. So that's how I'm going to get these numbers right here. Okay. And bada bing, bada boom. Done. Now on a test or quiz, sometimes they'll use prime notation. So I would call this x prime, y prime, z prime, because that's after the first transformation, right? But if they ask you for a double prime, for example, this is x double prime, this is y double prime, and this is z double prime, which means 2 apostrophes, that just means that it came after both transformations have been applied, okay? But again, the important thing here, guys, was in order to do this transformation, I didn't go back to the one over here. I only went back to this one. So I did the transformation on the new coordinates. Now, of course, if you wanted to do this graphically, you could, right? Like I could actually take these points and flip them over, and then I could translate each one. But the risk that you run with graphing is that you're going to make a silly mistake. Like imagine you're me, right? And you make graphs that are, so let's just say a little bit messy. You may mess up. So this is a way to avoid the pitfalls that come with having to graph. Let's try another example just to make sure you guys are okay with this, okay? And we're gonna take a look together at actually the next page, which is page 20. I'm sorry, the 20 is not written there. I think it must have just been cut off, so I apologize for that. And I wanna look at example number 5. Once again, which example? Number 5. Okay, let's take a look. Okay, so let me write out my coordinates, L, M, and N. Okay, L, M, N, 0, comma 3, 3, comma 4, and 1, comma 2. Awesome. Okay, first things first. They want me to do a 180-degree transformation or 180-degree rotation about the origin. Do I know a coordinate rule for that? Rhetorical question. Yes, of course I do, because I've been studying for the past couple weeks, right? Okay, so I get negative x, comma, negative y. So in other words, all I'm doing here is I'm just changing the signs of both the x and the y. No order switching. So let me write out my new points. So 0, negative 3, negative 3, negative 4, and negative 1, negative 2. Are there any questions? Silence. I mean, if there are, you're welcome to ask me later, but I'm going to assume that that's pretty easy, just changing the signs, right? Then they asked me to do a dilation with a scale factor of 2 using the origin as the center. That last part's really nice, right? Because since this is the origin, my coordinate rule would just be 2x, comma, 2y. And guess what? What do you think I would multiply each of these coordinates right here by? I would just multiply them by 2. So this is going to become 0, negative 6. This is negative 6, negative 8. And this is negative 2, negative 4. Bam! Done! And so in this particular case, we would say that L double prime is 0, comma, negative 6. M double prime is negative 6, negative 8. And N double prime is negative 2, negative 4. I don't know why there's only one apostrophe there, guys, and I apologize for that. It really should be double apostrophe. Oops. Maybe I'll fix that on the copies. But anyway, technically this should be L prime, M prime, N prime. These would be the final images. So long story short, how do you perform a sequence of transformations? You perform one right after the other. The important thing to remember, and this is what sets it apart from the regular old transformations, is that because you're doing multiple, when you want to do the next transformation, you go back to the new coordinates that you just created.